sigma tau I alpha. So if you see an object translating, like the letter M, which is the mass, we will use sigma F equal MA. For the object that is only rotating, we will use sigma tau. This equation is for this guy. This equation is for this guy. This is the set of equations to solve anything. My question now. What forces are acting on this guy? Gravity down. Tension up. On this guy. What is the force that is making able this poly to rotate? Yeah, but the gravity of the rod is not acting directly. The weight is not acting directly on the poly. There is no friction. Tension. The tension. If there is no cord, the poly won't move. Look. It's moving? It's moving. No. As soon as I do this, look. It's moving. What appears that was not before? What is now that was not before? The string. If there is no string, this doesn't move. Now it's moving because there is a string. So what is the force that is making the torque? The tension. This torque is tensional. Tensional torque. Sometimes called torsional. So we have the tension. This is my row diagram. Everybody's there. So if I draw my free body diagram, I have to set the direction of motion as the positive. What is the direction of motion here? Down or up for this guy? Down. If this is going down, the poly only can rotate in one way. Which way? Counterclockwise or clockwise? Clockwise. So my positive direction for this equation is this clockwise, and for this is down. This is my positive direction. So if I want to set this equation, what will be? What will be this equation? Sigma F equal MA. If it's going down, how will look my equation? Mg minus T equal to what? MA. This is my equation for translational motion. Nothing changed. What we are adding now to the chapter, that now there is a poly rotating. We have to consider the rotation of the poly. So, sigma tau equal to I alpha. What is the only force creating torque? The tension. If the tension is the only force creating torque, we only have torque due to the tension. What is the formula for torque? R. So in this case, what will be R? What is the R? Distance from the axis of rotation to the point of application of the force. The radius of the poly. Time F. What is F? Tension. Sine of the angle between the radius and the tension. What is the angle? 90 degrees. What is sine of 90? 1. We have maximum torque, correct? At 90 degrees. So sine of 90 is 1. So I get RT. On the other side, I have I alpha. What is I? For the disk. Let's assume that the poly is a disk. 1/2 mr squared. Time what? Alpha. What we are looking for? What we are looking for? Acceleration linear, acceleration angular, and tension. Do you have in these two equations those three things? So somehow we have to work with those equations to figure it out. That's it. So what can I do? I can divide by R both sides. Is that correct? Yes. If I divide by R here, this and this cancels out. I have 1/2 MR this. How A and alpha, now I have 3 unknowns and 2 equations. It's impossible to solve in math 3 unknowns with 2 equations. So we need to read off one or look for another equation. How A and alpha are related. Look at the formula. This, the summary of what we learned so far is there. A tangential is equal to what? Alpha R. So if A tangential is alpha R, I can change this. So my equation will look like this. Minus T equal MA. Is that correct? And T, because I moved the R to this side, equal to 1/2 M R alpha. But alpha I will replace by A. What will be? Alpha I will replace by I will put it in terms of A. What will be alpha? A over R. So what will happen to this R and this R? And now I can add the 2 equations. If I add the 2 equations, what I get on this side? Equal to what? Here I have the letter N, and I will factor out A, and plus 1/2 of the capital N times the acceleration.